In this tutorial, we're going to look at how we can create the basic sign that you can see here. We're going to look at how we can draw up vectors for the Avalon nameplate, and then we're going to take those vectors and we're going to look at applying some toolpaths to them to create the sign that you can see here. We're going to primarily be looking at the pocket and the profile toolpath, and we'll finish off by showing you how you can save out your toolpaths. So let's go to File, and then we'll go ahead and close out here. So let's start by creating a new file. So here we specify our job type, whether that's a single-sided job or a double-sided job. In this case, we are just looking at machining on one side, so we're going to use the single-sided job option here. Then we need to specify our job size, so that's your width, height and thickness of the part that you want to create. In this case, we're going to have that set to a width of 7.5 inches, and then we want the height of this to be 3 inches, and we want the material thickness of that part to be 1/4 inch. We can also switch between units, so you can set that to be in metric or in inches. In this case, we're just going to go with inches in this example. Then we need to set our Z0 position, where you can set that off the material surface, as indicated by this red dot on the top of the material surface in this graphic, or you could set that to be at the machine bed, in which case we're going to set this to be off the top of the material surface. Then you can specify your XY datum position, so this is your X0, Y0 position. Currently it's set to the lower left. We can see that indicated by the red dot in this graphic. We can also see that indicated in our job over here using this red square. In which case I want to set our X0, Y0 position to be in the centre of our part, and you can see that now that we've updated that, you can see that that red square is now in the centre, and this is now our 0, 0 position. And then we could simply go ahead and press OK. So now we can start to think about drawing our vectors, and we're going to start by drawing the main shape for our sign. So to help us, let's go over to the Create Vectors section of the Drawing tab, and we're going to look at this tool here to draw a rectangle. And if we click on that, that's going to open the Draw Rectangle tool. There are several ways which you can draw rectangles using this tool. Firstly, you can just go straight into the 2D view, and then using your left mouse key, you can simply drag to draw out a rectangle. We just press Ctrl Z just to delete that. The other option is to actually put in precise values of where you want to draw your rectangle from and how big it needs to be. So we're going to look at doing that for this example. Okay, so first off we can specify our anchor point. Okay, so I want our anchor point to be from the centre of the rectangle, where I want the centre of the rectangle to be at X0, Y0. So it comes out from the centre over here. Then we can specify the corner type, so we can choose square corners, radius external corners, or radius internal corners. And you can see the graphic updates there to give you a good idea of what type of corner you'll be creating. I like this corner, so let's go for the radius external corner. And we're going to set a radius here of 0.15. Then we need to specify the width and height of the overall rectangle, in which case we're going to go with a width here of 6.8, and we're going to have a height here of 2.4, and then we can press create, and you can see that's created that rectangle for us based on all of the information we've input within this form. Okay, so I'd like to create a new rectangle whilst we're still in the form here to create a border. Okay, so here we're going to have the anchor point again at the centre where X is at 0, Y is at 0. We're going to go with another radius external corner rectangle here using the same radius of 0.15, and then we need to specify the width and height. So this time we're going to go with a width of 6.5 and a height of 2.1, and then press create, and you can see it's created that for us there. And we can close out, and here we have our 2 vectors that we've just made. So now we're going to look at creating the Avalon text. So to draw text, we go back into the Create Vectors section of the Drawing tab, and we're going to use this option here to draw text, and that's going to open up the Create Text form, where we simply enter in the text that we want to create. For example, we can start to type in Avalon like so, and we can see straight away that the text is of a very large size, and we can see the text height here is at 11. So let's just alter that. Let's make that 1.3 in this case. Okay, we can see that's been positioned there. We can see it's positioned from the center, and we can move that around if we wanted to. In this case, we'll just leave it, and we'll look at recentering that afterwards. Okay, so the text height is good. However, I'd just like to change the font, and we can change the font by using this drop down list where you can search through all of the fonts that are installed on your PC, in which case we'll just go with Arial here. Okay, and then what we can do is we can just simply close out, and then with that text selected, we can simply use the alignment options just to align that to the center of our job or the center of our material using this option here. And then we can simply close out, and there we have our Avalon text, and it's aligned to the center of our job. So now we have everything in place ready to start creating toolpaths. So to do that, we can simply switch over to the Toolpaths tab using this icon over here. That will temporarily close out of the Drawing tab, and it will open up the Toolpaths tab on the right hand side. So the first and most important thing that you should always do is just check over your material setup before calculating any toolpaths. So we're going to use the set option here, and that's going to open up your material setup form. So here, what we want to do is we just want to go over all of the settings we've got here, ensuring that they're safe and appropriate and that they are following the dimensions and the setup that we're going to apply to the machining side of things. So taking on your material piece, what the thickness is of that, so you can double check that. In this case, we're going to leave that at 1/4 inch. XY datum position. Now on my machine it's set to the lower left hand corner, so I'm going to set that from the lower left hand corner here. So you need to do this according to the way your machine is set up here. Your Z0 position, we're going to set that off the top of the material, so we're going to keep that set to material surface. And then we move on to the rapid Z gaps above the material, so we're looking at clearance and plunge settings. And again, this is very much machine dependent. So the clearance is basically the height above the job at which it's safe for the cutter to move at rapid or maximum feed rate. And then the plunge is basically a gap that the tool will rapid down to during plunge moves. And so we're just going to leave these set to 0.2. That seems safe enough for our particular setup, but as always, you would want to make sure that that's also appropriate for your own setup, ensuring that you're clearing any potential clamping mechanism that you may have on your job so that the tool doesn't go into these mechanisms. So please check over your own clearance and plunge settings, ensuring that they're safe and appropriate for your machine and your setup. Then you're going to check your home and start position. Okay, so this is just ensuring that you're starting off safely at X and Y, and in my case we're going to leave that at 0, 0 with a Z gap above there of 0.8. So we're just going to go ahead now and press OK. So now we can start to create our first toolpath. Now we would like to machine in between the text and this inner border here, where we specify a distance that we're going to machine down into to machine that area away. So to do that, we're going to look at using the pocket toolpath. Now the pocket toolpath can be found under Toolpath Operations. It's the second icon in the list, the pocket toolpath, and if we click on that, that's going to open up the pocket toolpath form. So first off, what we need to do is we need to tell the software which vectors we want to create our pocket from, in which case we're going to take this inner border. Whilst holding down the Shift key on your keyboard, we're going to select the text. It's going to look at machining everything in between this border and the Avalon text. And so coming over to the Pocket Toolpath form, let's just have a look at everything in here and we'll work our way down. So first off, we need to specify our start depth. In this case, we want to start that at the top of our material, which we know is at 0. So we're going to leave that at 0. Then we need to specify our cut depth. So this is how far down you want to machine into the material, in which case we'll go with 0.1 of an inch. Next up is our tool selection. We can see we currently have a 1/4 inch end mill in our list. That's not the tool I'd like to use, so I'm going to use the remove option to get that out of the list there. And then what we can do is we can use the select option here to open up the tool database, in which case I'd like to choose an 1/8 inch end mill, which we can see all of the information for that tool is listed here. We can see the diameter, we can see the cutting parameters for this tool, along with the feeds and seeds that are set according to our tool database. So we're going to use the select option here. But then what we're going to do is we're going to use the edit option, where we can look at editing any of these fields for this tool, for this particular toolpath, and it won't affect the information that we have stored in our tool database for this particular tool, as we're just altering this on a tool per toolpath basis. So we can see that we have a pass depth here of 0.0625. Now we're just going to adjust that. I'm just going to make that 0.05 in this case. And for the step over, we can see that that's at 0.05, which is at 40%. And we can look to alter that. So let's just change the 40 to 20%. And you'll see it now that I've entered the 20 in there. It's auto entered in the actual value that would be, which is at 0.025. And obviously we do have the option to just type in the values for the step over here. Moving on down, we can then look at altering the feeds and speeds for this particular tool. And again, this is all according to how your machine is set up. So really you want to think about the machine you're using, the material you're cutting into, and the tools that you are using, ensuring that everything is safe and appropriate for your own individual setup. So in this case, I'm going to just look at reducing the spindle speed here to 12,000 RPM. The feed rate is currently at 40, so we can just look at increasing that to 60 inches a minute, and then have the plunge rate, we'll just reduce that down to 10 inches a minute. And we could go ahead and we can OK that, and that will just save the settings for the 1/8 inch end mill for this toolpath only, and it won't actually interfere with the information that we have stored in our tool database for that 1/8 inch end mill, which just gives us plenty of options just to make edits on the fly to tools for particular toolpaths. So now that we have our tool selected, we can move on and think about how we're actually going to machine this. We've got two options. We have the offset strategy and we have the raster strategy. So judging by the graphic, you can see that we're demonstrating what the pattern a raster machine will look like. So it just goes back and forth on itself, and you can alter the angle if you wanted to. For example, if you wanted that going up the y-axis, then you'd set that to 90 degrees and it will go up and down, up and down. You've got the offset strategy, which basically works from centre out, and it just follows the shape of the part you're machining. So we're going to look at using the offset option. Working our way down the form, we also have the option to apply a ramp plunge move. So rather than the tool just plunging directly vertically into the material, we can check this option and it will ease into the cut by machining diagonally into our material. And we can apply a distance here. So for example, let's just go with a ramp of 1/2 inch. So what that'll do, it will just ramp diagonally into the cut at 1/2 inch and then back in on itself before it starts machining the toolpath. It just helps with the wear and tear of the tool by applying these diagonal moves rather than plunging directly down into your material. And then we can simply give our toolpath a name. So for this case, we're just going to call that pocket 0.125. And that's just for my own reference to tell me that that's the tool that I'm going to use for this particular toolpath. And then you simply go ahead and then press calculate. And then the software will automatically open up the Preview Toolpaths form along with the 3D view so that you can visualize what the toolpaths will look like. So you can see there is an awful lot of lines that are visible here. We're just going to talk about each one of these lines and what they actually represent. So if we pop that in the ISO view and we'll just zoom in ever so slightly. Okay, so the red lines, our red lines here represent our rapid moves. So for example, we're starting at 0 and it's just going to do a rapid move over into position where it will then plunge down into the material, where you can see the plunges are represented by aqua lines. And then once it's plunged into the material, it's going to start feeding through, and that's what these dark blue lines are. Once it's done one pass, you'll find a green line, which you can see are dotted around in various areas of our job. These green lines represent retracts where the tool will lift up and then move on to the next cut. So it'll have a rapid over here, plunge down, and it's going to machine everything out, and then you'll have your retract out again. So that's pretty much all of the lines and what they represent in the 3D view. Now in terms of visualizing your toolpaths, we just put that back in Z. We can see we currently have what looks like a wood material. Now if you wanted to change that so it's more appropriate to the material that you're actually cutting, for example, let's say we wanted to machine this out of metal, well, we can alter the appearance of what we're seeing here by using this icon here where we can edit our material settings, and you can see that we now have a drop down list and we're able to choose a different material from within our list. So we have various different options. We've got woods, we've got metals. You can add in your own textures by using the add new texture option, where you can simply select a bitmap of the texture you want to use. In this case, we'll go with Steel Bright, and you can see that's automatically updated that for us there. So then what we can do is we're now able to actually preview our toolpaths. So we can look at adjusting the speed of our preview if we wanted to. We could use the option to draw the tool so we can see it in motion. And if we go ahead and preview that toolpath, we can see exactly what we'd expect to see on the CNC machine. And we can speed that up if we wanted to. And you can see that with each notch moving up the slider, it's just getting a lot faster. And this is purely just to see, just for you to be able to just really slow it down to get a better look at where your tool is machining. But then you also have the ability to really speed that right up so that you can just have it on the maximum speed setting so you can see what's happening in here much quicker. Okay, so that is our first cut. So you can see that that's machined everything away between the Avalon and the inner border text, machining down to the 0.1 that we specified. And if we wanted to, we could look at further altering how this is previewed in our toolpath preview. Let's say we wanted to paint that up in a green colour. Well, we could simply take that and go to the toolpath colour and then use this option here, select green, and then you can see it's just updated that there for us there. So we're always getting a good indication of what our parts is looking like in this toolpath preview. And so if you're happy with how it looks here, then you're pretty much ready to go to actually cut that out on your CNC. So let's just put that back in the Z, and then we're just going to close out of the Preview Toolpaths form. So now we're going to look at creating a cutout path, and that's going to cut our sign out of our material. So let's just tile our windows so you can see the 2D view on the top and the 3D view on the bottom. And then in order for us to cut this vector out, so we're going to select that vector, and then we're going to go over to the Profile Toolpath. And if we click on that, that's going to open up the 2D Profile Toolpath form. And we can specify how we want to run a profile pass with this vector. So here we're starting our start depth at 0. So remember, on the material surface. We're going to cut all the way through our material. So we can type in Z followed by the equals key, and the software will automatically fill that field in with whatever thickness we've specified in our material thickness form. And so it's picked that up as 0.25. Next up, we can then specify our tool. So we can use the select option here, in which case I'm going to use the 1/4 inch end mill to cut this out. And again, we can use the edit option just to check over all of the settings, ensuring they're safe and appropriate for our particular setup, in which case I'm happy with this, so I'm going to go ahead and press OK. Then we need to choose how we machine those vectors. Do we machine them on the outside, the inside, or on those vectors? And you can see that the graphic updates according to which button I press to show you exactly what that means. So when we're machining on the vectors, the center of the tool is on the vector. On the inside, the edge of the tool will be on the inside of that vector, and on the outside, the edge of the tool is going to be on the outside of that vector. And this is the option that we want to choose. Again, we can choose to apply a ramp plunge move here, so going in diagonally rather than plunging vertically into our toolpath. So we can go with a distance, again, let's go with 1/2 inch there. Now, if you had an appropriate hold down system, for example, like a vacuum hold down system, or you were using double-sided tape to hold your parts down, and you didn't really need to think about how your part is going to be held to the rest of the material, then you can go on without adding tabs to your toolpath. In this case, I don't have those luxuries of a vacuum hold down system, so I'm going to check the option here to add tabs to my toolpath, and what it does is it adds little tabs to my part where it will hold it in place to the rest of the material so that it won't fly off when we come to cut out this toolpath. And we can alter the length and the thickness of our tabs. So for example, we could specify that we wanted a length of 0.15 and we wanted a thickness of 0.08, for instance. And then we can use the option here to edit our tabs. And this is where the software can put those tabs in, or we can manually place those tabs ourselves. So let's just let the software do the hard work for us. So we're going to put in a constant number of 4. We also want to use this option here to avoid corners and curved regions. We don't really want our tabs placed on any of our corners here. And then we can use this option here to add tabs. And you can see that those tabs have been added into our 2D view. They're indicated by the yellow square with the letter T for tabs. And if we wanted to move them, we can just simply drag them around. If you wanted to delete them, you can simply click on those tabs to delete them. And then if you wanted to insert tabs, you can simply just click anywhere on your vector to insert those. So we're just going to go with the constant number, and we'll just let the software auto fill that in for us. And then we can simply close out. Then we can give the toolpath a name. So in this case, I'm going to call this one Profile 1/4 inch, and then we'll just press calculate. And again, you can see that what the software's done is it's opened up the Preview Toolpaths form. And if we just go ahead and maximize the 3D view, we can take a look at what we're seeing here. And if we just take a look at this, we can see that the toolpath is going to come over here, it's going to plunge down, and we're going to cut one pass out like so. Then it's going to come down and then cut the second pass, where you can see you'll have these lifts in each position that we had our tab, and so that's going to keep those tabs in place. And then we can simply go ahead and preview that. So let's just reduce the speed, then we'll go ahead and preview that toolpath. So there's your ramp. And then it's going to follow round, where it's going to complete the first pass, and then it will ramp back in again, like you can see there. And then you can see now those tabs are appearing, and that's holding our part in place. And so there is our finished sign, and at this stage I think I'm happy with what we've got for the profile toolpath. I can see that those tabs seem to be quite sufficient enough in terms of their length and the thickness, that's going to hold that nicely into position. And so at this stage it would be a case of thinking about saving out our toolpaths. And so to save our toolpaths, let's close out of the preview toolpaths form. So let's go into the save toolpath option. Okay, so at the top we have save selected toolpath, and we can see the toolpath to be saved is currently showing as the 1/8 inch end mill, and that's because this one is currently highlighted. If I click on this toolpath, you'll see that that will be updated here, and it's telling us that we're going to be saving this toolpath. Now, if we wanted to save out both of the toolpaths, we could look at various other options. So let's switch on the visibility of both of those toolpaths. We could look at saving visible toolpaths to one file. Now this would be good if we had an automatic tool changer. Now as I don't have an automatic tool changer, I cannot use this option. This is why we're seeing this error. And so we need to look at a different option here, whereby we could look at outputting visible toolpaths to multiple files. And we're going to do just that. And we can see now the toolpaths to be saved are listed here. We've got the pocket 1/8 inch tool, and we've got the profile with the 1/4 inch tool here. And so we can use the save option, and that will save out 2 different toolpaths to one file. So for demonstration purposes, we're going to save that to our desktop machine that uses the post-processor G-code ARCs inches. And you'll need to ensure that your machine and the post-processors for that machine are used here. And you can learn more about machine configuration and saving toolpaths in the related videos section for this tutorial. So here we're just going to use the save toolpath option, and we can give this a name. So the software automatically creates the file name based on the first tool or toolpath name that we have in our list. In this case, we're just going to change that, and we're just going to call this one Avalon, and then we can simply go ahead and press save. And then if we open up that folder, we can see that it's named our toolpaths appropriately. So Avalon 1 pocket 1/8 inch and Avalon 2 profile 1/4 inch, and these .tap files are what I'll go and take over to my CNC machine to then cut out the Avalon sign that we've got here. So let's just close out. And so that completes this getting started guide on how to create this Avalon nameplate. So let's go ahead and save the files. So here we'll go to File, Save As, and in the project folder we're going to call this one Avalon Nameplate Getting Started. Save that out, and you can access that from the project folder.